Hello, LabVIEW enthusiasts. Welcome to another video. This is on the Hooovahh Tremendous TDMS toolkit that you can find on vipm.io or lavag.org. Once you install it, you'll have a palette that looks kind of like this with a whole bunch of cool TDMS functions. The main one that I want to go into is this Tremendous TDMS logging. In here, you'll see 4 different initialization functions for the different classes, and then some malleable VIs that can write data, and then a close at the end. Included is a subpalette for examples, and here's 4 examples for each of the 4 classes. And I'm not really going to have enough time to run through all of them, but I'm just going to do a high overview of what each of the classes do and why you might want to use them. So here's the first one for a circular buffer. The idea is you give it a TDMS file that you want to create, you say how big you want your buffer to be, and you run it. And then it will keep only the last that many seconds worth or time worth of data once it stops running. And the API tries to make things simple, so it's just initialize, we write some basic data, and then we continually write data in this loop until we stop, and then only 10 seconds of it will be written. And if we have this as a compress, then it'll be written as a zip. If you don't have it compressed, then it'll just be that single TDMS file that's made. And that's pretty useful for like a black box kind of recording where you're constantly logging data, but at the end of it, you really just want to know leading up to the stop. So maybe something aborted, you want the logs of why they aborted and the data leading up to that. And this is all done with in-memory TDMS files, so this compression should be relatively efficient. It's not like it's writing to disk constantly, it's just writing to memory. Something to think about for the pros and cons of how to write these files that could be an issue for your system. Here's another one that is using the second class type for periodic logging. You give it a path of where you want the first TDMS file to be. You say, I want to create a new file every so many seconds. And then what it will do is it will just make a new file as the test goes on. So it'll start with the first file, and then the second will have, parentheses 1 as the file name, parentheses 2, that sort of thing. And the API, same thing. Just initialize, use the same write functions that we were before, and clean up, close. The third one is dealing with the size. So we might say, I want to make a new TDMS file if the TDMS file is a certain size or larger, in which case it'll make a new file. API, guess what? Very similar. The only thing with this is, for this example, I had to write how often do we flush the file, because for short demos like this, it won't automatically flush. For your setup, you probably won't need this. This is actually bad for disk I/O performance, but it's needed for this example. And the fourth one is based on the time of day. So if we want to create a new file, if a time of day has passed. So in this case, we're saying at 1600 hours and 42 minutes, create a new file. There's some issues with time zones and stuff like that, so this might not work exactly at that time, but for my purposes, it was really just on a new day. So if you set this to 0 and 0, at midnight, it'll create a new text file, or not text file, TDMS file, and start logging to that one instead. And then the old one will be closed, and you can do stuff with it. Your software shouldn't be writing to it anymore. So these are all the tremendous TDMS logging. And again, these 3 functions are all polymorphic using the different classes. And the initialization is really all that's special about it. Going up a palette, we have Excel conversion tool. This is really neat because a lot of people like TDMS for various reasons, but it's not as easy to consume. So this is a tool that will create a whole bunch of TDMS files and then convert them all to Excel. And it's got a whole lot of code behind it that relies on the Excel importer tool, so you'll have to have that installed to use this as well. Rearranging channels, it's a demo that just shows loading a TDMS file. You can rearrange the channels and save it. And it's just a demo to show an easy way to rearrange stuff. TDMS files don't have to have an order, so this is really just for reporting purposes, but I found a use for this, so I threw it in there. Writing and reading clusters to TDMS files. So we can look at the help on this, and you can see that you're writing an array of clusters, and that will be written to a group and channel just like any other normal TDMS. And same with the read, that you need to tell it the type, and it will return that type as an array saying how many samples do you want to read and at what offset, just like the normal TDMS read functions. There's an additional close that just does some extra steps that aren't probably needed for most people, but it allows for non-standard file extensions among other cleanup operations that the TDMS close doesn't just do on its own. For TDMS file operations, there's a subpalette for copying, deleting, and renaming TDMS files, and the only purpose of that is so that we can bring along or delete or copy the index files if they exist as well. Otherwise, they just do normal file I/O stuff. TDMS files can be combined in really interesting ways, and so I made this polymorphic VI that has a bunch of different combining options. So we can combine multiple files into one, or we can append files to existing files. And so this would be like, here's TDMS file 1, here's 2, append it. Otherwise, you're taking one file and appending a whole bunch to it. And that file might exist or not, and then there's options for merging index files. This is quite handy for really advanced file I/O stuff. We have saving in-memory TDMS files to zips. I mentioned that some of the other tools that have compressions will use this, and it's a really handy thing to be able to save files without hitting the disk I/O for performance reasons. And this is just an extension of that, being able to add multiple TDMS files to existing zip files. Split, this isn't all that useful, but what it does is it helps try to, if you have a corrupt TDMS file, it'll try to extract the non-corrupted sections of the file so that you can at least get some data back out of it. And then lastly, here's this, is it fragmented, which is useful to know. Sometimes you might want to defrag a file during test if it gets fragmented, because its I/O performance will be really slow if the index file ends up being really large. So again, these are all on vipm.io. There's discussions on the Lava forums, and any feedback is appreciated.